Alright, we're back to making another video. The last part of that last video and stuff, yeah. Quite complicated as you can see and stuff. It's something I've never discovered before, so yes, discovering it for the first time. I'm gonna have to see it multiple times to understand it, but let's move on. Picking up where we left off in our last video, we are going on to C++ templates. This one I kind of understand a little bit more. I've discovered this one before, and I kind of remember it a little bit, so. Templates let you write a function or a class that works with different data types. They help avoid repeating code and make programs more flexible. So function templates. You can create a function template by using the template keyword. Okay, and we got some syntax here. So let's start off with clearing out all this. I don't know if we're going to use any of this or not, but for now we are going to start fresh. Okay, so got some syntax here, so we're going to put that into the comments down below here. Template. It looks like this will be the syntax for it. Type name T, return type function name. It has been a while since I've seen this, but parameter code right here. Okay, so that is kind of our syntax for how a template looks. So T is a placeholder for the data type like integer, float, etc. You can use any name instead of T, but T is common. So this right here, even though it's set to T, I'm going to go ahead and add a little bit more to this right here. T is common, but any name, letter, word is optional. Okay, T is the common thing you'll see, but yeah, any name, letter, word, etc. So maybe if you have multiple templates and stuff, then you might have different names for them. Or maybe if you have a template that's describing something specific, then you might use the description of it instead of T. But this is normally how the common thing to use. So then we got an example here. So let's go ahead and get this example started. I'm going to kind of guess, put a space there, that everything above and below is still the same as what it always has been. Meaning that we would have the library right here, and then they're putting the template right here, and then we got the main as well. So template type name T T add T A T B. Return A plus B. And in this case, as we've discussed before and stuff, which ones need these semicolon and which ones don't. In this case, yeah, you don't need it. At least it doesn't look like you do. So, and then we got some rest of the examples in the main. So standard output, add int 5 and 3. And then new line. Did it again. How many times am I going to do that before I remember to start doing that properly? Standard, another output here. Add double. Two 2.5 and 1.5. And then another new line. All right, that's the end of the example right there. So it looks like template. Template kind of looks like, I'm not sure if it's, this more looks like a function to me. So this part right here looks more like a function to me. But in this case, instead of giving it a type right here, we are creating our own type, T. Type name T. And this is how you would do a template. Which means that this right here can probably accept anything. A string, a boolean, an integer, a double, etc. So we have two variables, both of them with the type T as well. In most cases and stuff, if it was going to be an integer, you would have integer and then int A, int B, and then A and B right there. If it was void, you wouldn't have the return, you would have void, and then string, whatever, string A, string B, and then you would just output the string right here. So in this case, we are using T, which first glance at this, especially seeing the code down here that it's outputting, it's going to be an integer. So the first time we run A or add, we call the function, in this case it's not a function, it's more of a template. No, I would say it is a function. I would definitely say that this is a function. I'm going to separate that. We're just declaring a type right here with this. This right here is just declaring a new type. And this is a function, which resembles an integer, something that has a return to it. So we're going to call the function. We're going to tell the compiler that our T actually represents an integer. So this right here is going to take place of this right here, telling the compiler that T is going to represent an integer in this case right here for this line of code. And we're going to set our since we have a parameter right here, our arguments right here, and then so it would end up printing out 8 for this first one, basically adding 5 and 3 as our variable names with the arguments and the parameters. But in the second output, we're changing it. So we're going to do add again. We're going to call the function add again, except for in this case, T is going to be represented by doubles. So it's going to be a double function. It's going to return still the same thing, add A plus B, which is why we have it in the angle brackets for both cases. First case, we're indicating what T is going to represent. Second case, we're going to change it and tell it what's going to represent in this line of code. And then we have two doubles right there, or floats. So when you use T, you're basically, in fact, if we wanted to change this, I mean, T is common, but I'm sure we can use type name number instead. And then change T right here to number. It's a type function number because we're going to use numbers. Because we're just basically making up a name that describes what type of function this is, a number function. And what the function is going to do is going to be add. So you see how I kind of changed that? So we're declaring a new type right here. We're giving it a descriptive name. Instead of using T, we're going to use number. So this is going to be a number type of function where it's going to add two variables together. Seems straightforward, simple, easy to understand, unlike the last video I made where it was kind of confusing. In this way, when we do the add, when we call the add function, we're going to replace number with what type of number it is. And then we're going to add the numbers together like it's describing. So we were literally, instead of using T, I am literally using the descriptive words of everything. So it makes a little more sense to me. And it's also a little easier to explain as well. Because in this case, we are simply adding um, two doubles together. Let's see if we can, actually, you know what? We'll leave that like that. At the end of this video, I'll see if I can't play around with this a little bit um, and go from there. So we got our example done. In the example above, add integer. So this right here section is what it's referring to. Add integer with the arguments of 5 and 3 tells the compiler to use integer for type or for t. And now I would not recommend, if you're going to do this right here, I would not recommend changing this to integer, because then there wouldn't be a point in having the template name there, or changing this to integer. When you are declaring a variable or a new type or anything like that, don't use keywords that are already as a default to C++. So if I change this to int, then this code becomes just nothing. And in fact, I don't even think this would work in it anymore at this point. So whatever your name is, make sure it's not something that's already a default name or keyword. So it tells the compiler to use integer for t, and that's probably why they use t quite a bit, but still, while add double 2.5 and 1.5 tells it to use the double. Hopefully that makes sense. Let's keep moving forward here. C++ class templates. You can also use templates to make classes that work with any data type as well. So we got pretty much the same syntax here. Return type, function name. So this right here is not very descriptive. If you want it to, it's not going to always be a return type, because I'm sure I could use a string up there and stuff with a void and do the same thing, just in a different descriptive way, which is what I was going to try and stuff, and I will try that here in a little bit. But then this would not be the case anymore, because it would not be returning anything. But I was not going to actually change this right here. I was just going to output something else and put standard string in there instead, and then have two strings and for arguments to where it's adding the two strings together, like hello world. Anyways, moving on. Now the next syntax it's going to use, I'm going to go ahead and write this down too. Yeah. So we're going to still use this right here. In fact, I'll just go ahead and take this right here, copy it, paste it down here, and then class, and then class name. So this is the new syntax for a class right here. Code. There's that. Moving on to the second example, so that's the syntax for if you were to use templates to make classes. The example below defines a template class box that can store and display a value of any data type, and then create one box for an integer and another one for a string. So again, we got this right here. I'm going to go ahead and change this back to T until we get the example fully put in there. Okay. Actually, you know what? There was no point in doing that because I'm going to change all the code anyway. So the only thing I'm going to keep is this up here. we're going to create a class. Box is going to be the name of the class. Curly brackets. Set the first part to public. T value declared box. T v value v. Don't know exactly what I'm doing yet until I get this all written down in here. Put a space in there. Void show as a parameter for function. Output value new line. Oops. And then since this is a class, it has an ending to it there, a semicolon to close it off. And then in the main, we're going to get rid of all this. And box. Again, like before, when you called the function, you had the type that you were going to put in there. And in this case, box, we're going to create a type for it to put in there. Int box with a parameter of 50. Box. Standard string box. Hello. And that, and then down below int box dot show string box dot show as well. All right. Now we got the second example put in here. Again, we are declaring a new type right here. T doesn't really have any kind of definition to it. It's just open for whatever. Create a class. Name of the class is box. Setting this to public. T is going to be declared. Looks like we are calling the class. So calling a class within a class. And the type is going to be whatever is set and with a variable of v. So value is going to be set to whatever we put in here for this. And then going through the rest of the class, at the end of it, we're going to have a void function called show with 0 parameters in it, and we're going to output value right here. So whatever this ends up being is going to be printed up right here, value right there with the contents. And then the first time and stuff, so normally you would see what you would see would be box and int box, just declared to create the object. So box would be the class, int box would be the object you're creating. In this case, we first have to declare what the object is going to be. So it's going to be an integer type object. And then there's the object right there, and set the parameter to 50. That way when we come back into here and it's calling it at this point in time with the 50. If it didn't have the parentheses on it, it'd be just declared, not an actual call. No, I'm wrong about that. We're setting a type, giving an object, and giving the object a value. That's what we're doing. So we are still just declaring it. So the box is going to have an object of int box. The type is going to be integer. The value is going to be 50. And the same thing for this, except for instead of being an integer, it's going to be a string and the string value. Okay. And down here is where we're actually making the call. So the first one is stuff calling class, um, actually calling the function show in the class box with whatever value it had set into it. In this case, it's so these both have different names, two different objects, an int box and a string box. The int box is going to be set for whatever this value is right here, 50. So 50 is going to go in here for v. Value is going to be set to 50. And then when we output it, since we're calling the function right here, value is going to be 50. And then same thing for this one. So value is going to be changed since it's a string this time, going to be changed to hello. And we call it and stuff, value is going to be set to hello. And we're going to print hello right there. So if that's a little bit confusing, I understand that. I apologize for that. That's probably a little bit my fault. Again, I'm not trying to educate on anybody on this. I'm just discovering it myself, and if I'm just sharing my journey of discovery. So, if anybody is confused and you have questions or whatnot, leave them in the comments there. Um, or you can try it yourself and stuff on this website right here to try to understand that, especially if this is the first time you're seeing this video. I got many videos out there now. Got many more to make. So, but yes, my predicted outcome is that we're going to print off value twice. The first time is going to be with 50. The second time is going to be with hello in the terminal. Let's go ahead and save this, run this. Yes, value 50, value hello. Because we called the using the class twice to call the void function show, setting the values for the parameter value or the parameter variable, setting a value for value. Yeah, that's kind of a redundancy too. So, moving on. So that was the first example right here where we're using class and setting it for integer and string. There's another example right here, and in this example, it defines a template class pair that stores two values of different types and displays them, then creates one pair of a person's name and age and another for ID and score. Okay. Okay. So we got some new code here. I can keep all this down here, it looks like. I just need to make some adjustments up at the top here. So the first one right here, it's showing us that we can actually create two different types, or two different templates. First one being T1, the second one, again, got to be separated by commas, type name. The second one's going to be T2. And then we're going to go down here to box and change the class from a box to a pair. So the name of the class will be pair now. Still set to public. Changing T1 or T to T1. Changing value to first. And then going to use T2 for second. So declaring T2 as second, right? Variable second. Change box to pair. If I could spell something. There we go. T1 is going to be set to A. T2 is going to be set to B. Then changing this to first. And this is going to be set to A. And then second, set to B. And then we're still going to have the void, but we're going to change this to display instead of show. No parameters in there. We're still going to have an output, but this time we're going to change value to first. Change value again to first as well. At that point in time, I'm going to, yes, I'm going to take it down to the next line. That way, I can get the second one in here. So the second piece of content, second. Okay. Except for it did not put my other colon there. There we go. Alright, so we got contents, and then first, right here, which is set to A, contents, second, which is set to B, so whatever goes in A and B right there will be printed out right here. It won't be a new line for each one, it'll be all on the same line. I'm just trying to keep it on the same page right here, so I moved it to a second line. Now we're going to come down to here and make some adjustments down here. Obviously, box is no longer our class name, it is pair. String instead of integer. Actually, string and integer. Int. So we're using two different types. Wow. Okay. And we're going to change the object to person. And then add a string in there for the argument, because we don't have enough arguments in here now. And instead of 50, we'll just change this to 30 to go along with the example. Same thing down here, change box to pair. How do I say it? Okay, so the second pair, we're not going to have a string at all. We're going to have an integer and a double. So we're going to clear all that. Int, double. It's going to replace the object name with score. And get rid of the string, and we're going to replace it with 51 and 9.5. And then we need to go down here as well and change two of these things down here. The objects and the show. This will be display. Same thing with here. Score. Display. Okay. So in this case, we're creating two types instead of just one. It looks like you can create as many types as you want and label them however you want. Give them new names or whatnot. So if you want to go up to T50, you can go up to T50. If you want 50 different ones in here. Type 1 is declared with the variable first. Type 2 is declared with the variable second. Type 1 is going to have in this class call on itself. Type 1 is going to be set to a variable of A. Type 2 is going to be set to a variable B. First variable is going to be set to whatever you put in for the variable A when you give the arguments, because this is just the parameters. The second variable is going to be set to the variable B when you send in the arguments. And then we're going to output first and second with whatever values you set for A and B down here. We got the contents and then the variable contents variable. Now we're going to declare our objects. The first one's going to be the class, what the types are going to be. So we got string and integer. The class, the object's name is going to be person. And it's going to be John for string because it's got to match, and this has to be in the same order as what it is over here. So whatever order this is right here, this has to follow that same order. Otherwise, you'll end up with an error. So since the first one's a string, John has to be the string. Second one's an integer. Now, if you had point whatever at the beginning of that, the integer would end up dropping off the point whatever. So we've created an object, given it parameters or arguments, for the parameters to match, and declared what the types were right here. And the second call, or the second object that we're creating right here for pair, it's going to be integer and double. So there's the integer, there's a double. The new object name is score. And then we're just basically calling it out and placing our arguments right here with the parentheses. We don't have to have the parentheses in here because we're just telling it, hey, use these up here. Person, person, display for the function up here. Arguments are there. It's got arguments with it, sort of thing. So this should print out twice, or not twice, but it should print out first John, second 30. And then there should be another line after that, so saying first 51, second 9.5. So when you're writing code, and this is something I have found when I've been playing around with it or experimenting with it, a lot of times, even in this, I've already got it saved, I'll run it. So we've gotten everything right here. The only thing I didn't add was that space right there. Save, run it again. There we go. So we don't know, I mean, we're practicing with the code, but when you see this in a terminal or in a window that you open up and when you run the program the first time, you have no idea on what it means by first and second. First, John, okay, and is his last name or second? Yeah, I don't get that. So you might have to write a lot more content so that whoever is seeing the window or the program that you're running is very descriptive. So that is a lot of code right there being descriptive in what you're setting the values for. Um, I have found myself to write a lot of content so that um, when seeing it in the output and stuff, because I'm trying to see it not in just my eyes, but if it was somebody else running my program, and I have no idea what the program's doing, I am simply trying to uh, be very descriptive in what the data is showing here. So, but that's the example right there. I'm sure I'll get into that later on and stuff when I get farther into this. Right now, it's like I said, more about discovery than anything else. So we have discovered templates right here, and that we can make our own types up, and we can adjust those types to whatever we want them to be when we create objects for them. We are putting values in there. We are calling out what the values are, calling out the functions. I mean, we're doing a lot here with this code, and there's a lot of different things done. So this is a unique thing about class right here. You can do this with a class. Moving on, actually, that's about it. So it does have an extra spot here. Why use templates? Templates lets you avoid repeating the same logic for different types. So instead of uh, in this case, the code is simple enough to where you can literally just declare a string type John, such and such, such and such, such and such, and get rid of a lot of this. I mean, you can remove a lot of this code and get this simple stuff done. But if your code is big or large, class functions, all these things that come up here and stuff are intended to be repeated more than once from the main. In this case and stuff, we're only using them twice, which means that this right here is kind of useless to have if we have it down here. And I mean, we've barely touched the idea of collecting data from somebody. So again, these are just examples. There is a little note here. Note templates must be defined in the same file where they are used. Now, we have not discussed anything about files as far as C++ is concerned. So just remember, templates must be defined in the same file where they are used, usually in the .h file, which that makes sense to me because I've already discovered this before, but to other people it may not make sense. We'll get into that later on. I'm not even sure if this really gets into, it might get into it in projects. but my other source gets into it much deeper as far as understanding what this right here means. So just remember, if you're creating a template, the template must be used in this right here. In the same file you created it in. If you're creating other files or whatnot, same thing. So just remember that, I guess. Moving on. So files, there we go. Anyways, sorry about that. Files. So that's going to be it for this video. We will pick up our next video with files, C++ files. I have no idea on what it's going to get into with this. I think I've seen this once before, but I'm not sure. Um, Especially when it comes to W3 schools. Again, if I've said something wrong, feel free to correct me in the comments. If you have any questions, so forth, you know the routine. By now, if you've watched any of my other videos, you've seen me said it before. So if you like the videos, hit the like button. We'll pick up in the next video with C++ files. Not a whole lot more left with classes, and then we'll be moving on to errors. So I will see you in the next video.